welcome to the Centremaps video. Today we're at the British Geological Survey headquarters, and kindly Katy and Russell have joined us and talking a little bit about the BGS 50k geology data set. The mapping's been built up over quite a long period of time, and I thought it was interesting to just reflect on how's that data come together, what was the original kind of drivers for people piecing together bits they were finding here and there into something more as a national coverage.
So the British Geological Survey has been making the geological map for the UK since 1835. There's been a very, very long history of geological mapping before that. So the first geological map of the UK was in 1815, the William Smith map. For much of the last 190 years, people were quite happy with paper maps. In the last 30 years, the advent of digital mapping and the advent of digital systems like GIS systems has meant that we've had to move away from the traditional paper map, and we've had to start making digital products for people to use. The digital maps are more convenient. You can have them on your phone. The digital maps work for us because we can manipulate them into other products. And the digital maps make it easier to edit things and adjust things and take on board new sources of information. So we use a lot of integrated virtual techniques to bring in lots and lots of sensor data now. We have had surveys that are airborne flown. We've used surveys that are satellite flown. So by compiling a lot more digital data, you need to be in a digital environment.
Yeah, the geology isn't changing, but the understanding is.
The understanding changes all the time.
Yeah, it's very easy, isn't it? You see the geological map and think, oh, that's between here and here, it's identical. It's all that type of geology,
Yeah.
and a geology is actually maybe a change in coastal environments over a period of time, but they get grouped together.
So this is really key for the evolution of the geology map. So we are known for BGS Geology 50 by having that digital environment and being able to play with different factors. So paleo environments are really important to understand what's going on there. Once you start adding in climate change, you start to pick up climate signatures in the geology, you can start to understand, okay, so this is what it was like, this is where we are, this is how we've changed, what does that mean? And again, it tends not to be just research-focused items. There are very pragmatic aspects to that as well. So we might understand that a rock type over here has certain engineering properties, and one over here looks exactly the same, but because of some local change, it is a much stronger rock or a much weaker rock, or has chemical signatures which are different.
I think as well as understanding the geology and the research, and that evolves over time, we've also got much more technology and techniques have evolved over time. So we're using more things like aerial photography now as well, LiDAR and things, sort of preliminary fieldwork assessments, and so that is evolved and continues to evolve quite rapidly, doesn't it?
We are much more efficient at analysing an area before we go. So when we go on the ground, we're much quicker at making a map. That's probably a good thing because it's become much harder to access parts of the UK.
Yeah.
So we deploy techniques to improve our efficiency. The downside of that is that the amount of digital data we're dealing with has risen exponentially. Yeah. So we gain in the fact that we understand an area quicker, faster, but we lose in the fact that then trying to work out how to convey that is actually a challenge.
And that's where the products and the interpretation
That's
comes
where
in.
all the other things come in. And sometimes that's not just us.
And I guess the understanding you build up as well, from a geologist's point of view, is quite a 3D understanding. Mm-hmm. And so you're trying to convey that in this data set as not 2D, but like what's at the surface.
So this is the really interesting thing about BGS Geology 50. It is our traditional 50k map product. It was analog, it was pieces of paper. We've made it two-dimensional, digital. In reality, the whole process of making a geology map is 3D. We think in 3D. We model in 3D. The problem is it's quite hard to share 3D. We have had a lot of very successful attempts to share 3D to a wider audience. They have issues as you're making them all the time. But we try and make it as consumable as possible so that people don't have to come back to us to always have us answer their questions. We try and make it simple. It's getting the balance in terms of what we make, in terms of is it useful to the widest audience we can manage.
I guess the 1 to 50,000 scale, because of all those factors, is actually probably quite an appropriate scale that people consider it, isn't it? If you looked at it at a 1 to 1250 scale and said, I can can see the boundary and the geology line there, and the house is just outside of it. That would be an inappropriate.
Yes, so this is something you come across a lot, because sometimes it matters. If you build half of your house over a geological boundary, you might have issues with engineering, which is why we issue engineering advice and hazard advice, so that engineers know either not to do that or to engineer so that the house is suitable for that. So there are very few areas where the geology is a no, but it's a good idea to understand what we're trying to say in the maps rather than just assume.
So I guess to talk about getting the data together, in the data that comes in 50k, there's a couple of different layers, and we'll just explain those.
So a standard BGS Geology 50k product is 4 layers that describe geological themes. So there's a bedrock layer, which sits at the bottom when you put it into your GIS system. And then there's a superficial layer. So these superficial deposits are younger than 2.58 million years old. They're Quaternary deposits. And then there is a artificial layer, which describes the urban growth of the UK and the industrial growth of the UK. We tend to focus on the bigger patches of urban development, so quarries and mines and things like that. And then there's a mass movement layer, which describes where things have moved due to gravity, so these are landslides. And then it's mostly for cartographic purposes, but there are a few important parts to it. There's what we call a linear layer. So this is a catch-all layer where we put into it all the linear features that make a geological map what it is. So in there are faults, there are lines that represent coal seams or mineral veins. There are quite a lot of really useful individual items, but it's quite tricky to put them into their own little box. So we put them in this linear layer, which kind of like sits over everything.
I think what's quite amazing behind that is, with the geology having the BGS lexicon links, the fact that you can look at whether it's superficial or bedrock and go through to a huge lexicon resource.
Yeah, there are a whole host of resources that we actually make freely available to everyone. So the one you mentioned is the BGS lexicon. So this is a very, very long list of names that describes the lithostratigraphy, describes the age of the rocks and roughly what they're made of, and it's how we explain why geology changes across the country.
And I think it points a little bit to BGS, as it is really a big scientific background, isn't it? It's down the map, as I say, over more than 180 years to now, the all that is somehow still managing to be brought together and made visible and available.
Yeah, this is what we call our public task. It is why we receive funding from the government directly to make research available. To do research, first of all, we do work with universities, we do bid for work, university research work, and it's a combination of doing that generic geology background and then also blending that with other things.
If you want to get hold of the data, you can license it from the side of the Centremaps. We do try and make it easy to use by putting in a layered PDF, which allows you to turn those bedrock and superficial on and off, and it also has the legend with just those rocks in your area, so you can get through to that lexicon and get all the detail about rock types. I've enjoyed today's conversation. I'm sure we'll have some other good ones around the other products soon. Thank you.